T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff!
When NASA's new launch system, SLS, has its first flight, known as Exploration Mission 1, it will carry the unmanned Orion spacecraft on a voyage to the Moon and back. It will also be carrying multiple small spacecraft as secondary payloads. SLS is the largest and most powerful American rocket since the Saturn V, and will eventually send humans farther into space than ever before. 2 minutes into the flight, the twin solid rocket boosters will burn out. About 10 minutes after the Orion and its service module escape the pull of Earth's gravity, the two will disconnect and Orion will proceed toward the Moon. On the SLS second stage, housed within the multi-stage adapter, are multiple small spacecraft known as cubesats. Cubesats are about the size of a large shoebox and weigh less than 30 pounds each. SLS is carrying these cubesats piggyback, which will give them a low-cost ride into deep space. Once Orion is a safe distance away, the small payloads will begin to be deployed. The dispensers on the adapter ring completely isolate the CubeSats from the SLS. They require no power and operate completely independently of the rocket. One of these CubeSats is called Near-Earth Asteroid Scout, or NEA Scout, and it will demonstrate a new capability for exploration: low-cost reconnaissance of asteroids. Asteroids to which we may one day send human explorers. Shortly after the NEA Scout CubeSat is ejected from the SLS, solar panels will deploy to provide the spacecraft with power. Next will be unfurled an 85 square meter solar sail. The sail, the length of a school bus, reflects sunlight and is the spacecraft's propulsion system. This is the largest solar sail ever deployed by the United States. NEA Scout will fly by the Moon, which will help send it on its way to the target asteroid. The key to enabling this low-cost reconnaissance capability is the propulsion system that will enable the NEA Scout to go from near-Earth space to a deep space rendezvous with an asteroid. Using the sunlight pressure, NEA Scout will continuously alter its trajectory as it moves toward its asteroid rendezvous. Sunlight particles, or photons, which in this case behave like tiny ping-pong balls as they bounce off the sail, push on the sail as they reflect from it. And since the sun is always shining, the thrust is continuous. However, it is very small, on the order of an ounce of force per football field of area. Once at the asteroid, NEA Scout's onboard camera will image its surface in detail, answering many questions about the asteroid's composition and history. Exploration Mission 1 will serve as a proving ground for the integrated Orion spacecraft and the Space Launch System. In addition, it will provide an enabling capability for flying interplanetary small spacecraft for science and exploration.